Okay, this is lesson 14, the conclusion of lesson 14. Let's start with the difference between coordinates, the point 2, negative 1, 1, 2, negative 1. This is the point 2, negative 1. But when we're talking about vectors, this vector is given in the form I and j. Your I-axis is what we've been calling the x-axis, and the j-axis is the vertical axis. He uses the ij designation to indicate that he's talking about vectors, not points. So this vector is positive 2 in the I, negative 1 in the j. A vector is a magnitude in a direction. So this rectangular description, 2i minus 1j, represents this displacement in this direction. So vectors have a magnitude and a direction. All right, we have two ways to describe vectors: polar and rectangular. All right, the ij is rectangular. Polar is the way we normally describe a vector. That's going to be a radius at an angle. A radius, a magnitude at an angle. All right, first thing, when we measure angles, we always measure off the positive x-axis. So this is my positive x-axis. Positive angles measure this direction. Negative angles measure clockwise. All right, so positive 100, where would that be? I don't have a magnitude yet, but we're just talking about the angle. Positive 100 going this direction straight up would be 90. The negative x would be 180. The negative y would be 270, going in the positive direction. This says positive 100, so we go to 90 and we go 10 degrees off the 90. So this is the angle positive 100 degrees. The angle negative 70 degrees, come down here, we're going in the negative direction, so this would be negative 90, negative 180, and negative 270. All right, so the positive y-axis could be called positive 90 or negative 270. This angle is negative 70, so it's not quite negative 90. It's 20 degrees off. So this is 20 degrees short of negative 90. So this would be a negative 70 degrees. All right, what about a positive 290 degrees? Well, let's see. Here's positive 90, positive 180, positive 270. I'm trying to get to 290, so I need to add 20 more. Wait, that's the same. This is the same angle. Negative 70 and positive 290 are the same angle. One's described in going in the positive direction, the other one's described as turning in the negative direction. Same thing with this negative 260. Negative 260, if I start here and I'm going negative 90, negative 180, negative 270, whoops, I went too far. How far? Too far did I go? I went 10 degrees too far, so I got to back off. That's the same. Negative 260 is the same angle as positive 100. All right, so that's half of a polar coordinate is the angle. So the first thing we do is we turn to the angle and then we go forward or backwards that radius. So magnitude of 4 at an angle of 45 degrees. All right, so this is a positive radius at a positive angle. So I turn to 45 degrees and I go forward 4. Now I would use a ruler and scale this to be 4 long. As compared to 2 and an angle of negative 45. Well, negative 45 is below the x-axis and I'm only going a magnitude of 2 this time. So if I were using a ruler, this radius would be half the length of that one. Negative 4 at positive 135. I turn to an angle of positive 135 and I move. I'm facing this direction, but it says to go negative 4. So I come this direction and I go backwards 4. Now see, that light blue was only 2, so this one's got to be 4. Whoops, this purple and that pink are to be the same size. All right, so what about negative 2 at an angle of negative 135? Well, here's negative 90, negative 180, so negative 135 is halfway in between. So I'm facing this direction, but I need to go negative 2, so that's walking backwards a magnitude of 2. So this one is negative 2 at an angle of negative 135. When you're asked to give your answer in polar coordinates, they're going to be asking you to give it in 4 forms. They're going to be asking you to give that answer in 4 forms. So suppose I just had, let's do something strange. Suppose I had negative 4 at an angle of 45 degrees. And I was asked for the 4 polar forms. Well, what they're asking you for is a positive radius at a positive angle, a positive radius at a negative angle, a negative radius at a positive angle, and a negative radius at a negative angle. All right, well, first of all, they gave us the negative radius, whoops, wrong color, negative blue, okay, the negative radius at a positive angle. So they gave us negative 4 at an angle of 45 degrees. Okay, so let's figure out where that is. We're going to first turn to an angle of positive 45, right? So that's looking up here. And we're going to go backwards 4. We're going to go backwards 4. So that's negative 4 at an angle of 45 degrees. Well, if this is 45 degrees, so is this one, right? Vertical angles. So if I'm talking about a positive radius walking forward, that's going to be a distance of 4, a magnitude of 4. But how do I describe this vector with a positive angle? I come this way, 90, 180, and 45 is 225 degrees. All right, well, how do I describe that same one with a negative angle? Well, negative 90, and not quite negative 180, 45 degrees short of negative 180 would be 4 at an angle of negative 135. 4 at an angle of negative 135. All right, we already saw that if I turn to this positive angle and walk backwards, that would be my negative 4 at an angle of 45 degrees. How do I describe this vector with a negative radius and a negative angle? Well, with a negative radius, I'm going to be wanting to face this way, right? I need to face this way. As a negative angle, negative 90, negative 180, negative 270, right there. I don't go all the way to 360. I stop 45 degrees short. So this same vector can be described as negative 4 at an angle of negative 315 degrees. All right, so that's how you do 4 angles. The real trick to these vectors is when we have to change back and forth from rectangular to polar and from polar to rectangular. We have to change back and forth. So rectangular form, I always say this is the rectangle in the I direction, in the J direction, that gives me my rectangular. So this is the rectangular form, and the polar form is the radius at an angle. So it's the exact same vector, it's just sometimes we describe it rectangularly, sometimes we describe it in the polar form. So let's look at this one. Negative 3 in the I plus 2 in the J. So I'm going to go 3 this direction and positive 2 this direction. So this vector is represented by 3 in the I and 2 in the J. So this is 2 high and 3. All right, what do you notice about this particular vector? It's in the negative I direction, in the positive J direction. So this angle right here is probably best described as a positive angle. It's less normally your calculator is going to give you everything less than 180. It'll either be between 0 and positive 180 or 0 and negative 180. So we're looking for this angle right here. But what I'm going to find, I'm going to call this one x, is this angle right here. All right, first of all, let's find the radius. All right, first of all, let's find the radius. So the radius comes straight from Pythagorean theorem. So the radius is going to be the square root of 2 squared plus 3 squared, otherwise known as the square root of 13. So the radius is going to be the square root of 13. Now how do I find this green angle? I first find this little angle x. I want to use the dimensions given to me, not the ones I calculated. So when I see this angle, I see what I'm given is the opposite side and the adjacent side. So what I know is the tangent of x is the opposite 2 over the adjacent of 3. So x is the angle whose tangent is 2/3. In our calculator we enter it like this. X is the angle whose tangent, second tangent, is 2/3. And the calculator, if you're in degrees, will tell you 33.69 degrees. So negative 3 in the I plus 2 in the j is equivalent to square root of 13, whoops, not quite there yet, but this x describes this angle. This vector is described by the green angle. So what is that? Theta is 180 minus 33.69 degrees. Right, because I'm in the second quadrant, I know I'm more than 90 and less than 180. That turns out to be 146.31. So negative 3 in the I plus 2 in the j is equivalent to the square root of 13 at an angle of positive 146.31 degrees. And of course you could change that to the other three forms as well. All right, now let's go the opposite direction. Let's be given polar and change it to rectangular. Polar, a radius at a magnitude, a radius, a magnitude at an angle compared to something horizontally plus something vertically, what we would normally think of as x plus y. All right, negative 13 and an angle of 253. Where is that? Okay, so we're going to turn to an angle of 253. Well, that's not quite 270, right? It's looking this direction. But we're going to walk backwards 13. So we're going to, whoops, sorry, I copied the problem wrong. Let's see. It's supposed to be negative 13 at negative 253. Negative 13 at negative 253. So let's try this again. That out of there. Okay. So negative 253 would be negative 90, negative 180, negative 270. Okay, so not quite negative 270. Negative 253 is facing this direction. But we're asked to walk backwards 13, distance of 13, a magnitude of 13. So I face this direction and I go backwards a magnitude of 13. Okay, so this is 13. All right, so what is this angle right here? Well, 90, 180, 180 plus what gets me 253? 180 plus 73 will get me 253. All right, well, if that's 73, when I come over here by vertical angles, let's see if I can make it a little darker so you can see it. By vertical angles, this is also 73 degrees. So what I need to find is this I value and this j value. Right now, we're going to recognize that in this quadrant, in the fourth quadrant, the I is positive and the j is negative. We just have to figure out how far in the I and how far in the j. We should recognize that right away as trig. I is the adjacent you know the hypotenuse is 13 and you know 73. So I is adjacent to 73. Adjacent and hypotenuse, we're going to use the cosine. So the cosine of 73 is I over 13, or I equals 13 cosine 73, which our calculator is going to tell us is 3.80. So we know that that's the positive I, so it's going to be 3.80 in the positive I. And then J is opposite, and we know the hypotenuse. So opposite and hypotenuse, we're going to use the sine. The sine of 73 is J over 13, where J is 13 sine 73, which our calculator tells us is 12.43. But we look at this and we say that 12.43 is in the negative direction. 43 in the J. Okay, the little carets represent vectors. I'm okay if you call it 3.80 in the X and negative 12.43 in the Y, but you have to make sure you're including that negative sign. The only way you come up with a negative sign is recognizing which quadrant it is, which requires a sketch. All right, okay, see you Monday.